page 243. It says a random variable has a probability distribution, whether it is discrete or continuous. We talked about discrete and continuous back in chapter 1. Discrete represents counting and continuous represents a measurement. On page 243, it talks about the features of the probability distribution of a discrete random variable. If you look at the video, we're going to talk about what's being read on page 243 and the table that you see before you. The table is a probability distribution. A probability distribution is an assignment of probabilities to each distinct value of a discrete random variable, or to each interval of values of a continuous random variable. So let's talk about those features right quick, and then we'll tie that into this table that you see. The feature, number 1 says the probability distribution, that is the table that you're looking at on the video, has a probability assigned. The probabilities assigned on the third columns, the P, X equal X, P of X equal X are your assigned probability. The 0.45, 0.34, 0.11, 0.04, 0.04, and 0.02. Those are your probabilities assigned. The probability distribution has a probability assigned to each distinct value of the random variable. The random variables are the number of ice creams, which is usually denoted with a capital X. The 1, 2, 3, 4, 5, 6 are your random variables. So just want to make sure that you understand that table. We're talking about the probability distribution, which is the table, the probabilities assigned, which is the third column, the P of X equal X, and your random variables are your number of ice cream. We want to make sure that we know how to read this table. Very easy table to read. The owner surveyed 500 customers. Out of 500 customers, we can see that 225 of the customers will purchase 1 ice cream. So that represents 45% of the total number of customers. To do the calculations there, all I have to do is say 225 divided by 500, and I will get to 0.45, which represents 45%. If you look at the next row, it is telling me that out of 500 customers, 170 customers may buy 2 ice creams. So that represents 34% of the total amount of customers. As the number of ice creams increase, notice that you have less customers buying so many ice creams. Look at the very last one. You have only 10 customers out of 500 that may purchase 6 ice creams. So they only represent 2% of our total amount of customers. That is how you read that table. On page 243, number 2, it says the sum, and we know sum means the answer to an addition problem. The sum of all the assigned probabilities must be 1. So as you look at this table, when we calculate our probabilities assigned,